So thank you, Christoph, for the introduction. And here the first presentation for this session is delivering network as a service with OpenSlice. So a little bit of a context before we start for those of you that are not aware. So OpenSlice is an open source operation support system that stands in place of OSS in the ETSI NAV architectural framework. And it tries to offer network as a service solutions leveraging ETSI NAV, ETSI ZSM, TM Forum, and 3GPP principles. At its northbound, it exposes TM Forum APIs and interacts with, at the southbound with NAV orchestrators, leveraging ETSI NAV APIs, and Kubernetes through its native API as well. Last but not least, there is work to try to converge the words of GSMA and especially the generic slice template towards the word of TMF. So before we start talking about network as a service, let's see the prerequisite. So we would like to have devices from far edge to the public cloud, and to have real network as a service, we want programmability. So these devices, we expect to offer controllers. The functionalities of the controllers should be exposed at the northbound as standardized APIs, so as to promote interoperability, and to expect external stakeholders, either by using UI or directly the API, to order end-to-end services. So when an order is captured, the end-to-end service orchestrator employs the underlying controllers so as to deliver the end-to-end service. And respectively, this service is exposed to the end-to-end user. So this is network as a service, and this box is where OpenSlice stands at this architecture. So a little bit of an architecture. So as you see, this is a service bus architecture. It comprises of many microservices. The main ones are the TMF APIs that are consumed by the respective UIs as well. An API that is capable of managing NAV artifacts. Of course, it incorporates typical authentication services, issue management, central logging, and the core components to interact with the controllers underneath are its specific clients. So one is the Mano client, which interacts via Solo 5 with respective NAVOs, and CRIDS, which is the component to interact with direct and native Kubernetes APIs. Currently, what is built and is going to be released at the next service is a service that enables closed-loop automation. So a service, Metrico, which is seen at this figure here, is responsible to orchestrate monitoring data capabilities and fetching this data to services that are running so as to close loops. Last but not least, the core component of OpenSlice is its own service orchestrator, which is responsible for delivering the end-to-end services. So let's start with the NAV support. OpenSlice allows service providers and customer to design and offer available service specifications. Also, the service specifications, where we talk about NAV word, has to be mapped to NAV-related artifacts, and this is why NAV developers can also onboard the respective artifacts through the respective UI. Also, there is direct access for third-party application via the API. So two portals are responsible for this, the service portal and the NAV portal, and also the TM Forum APIs that are exposed for public usage. When we come to cloud-native support, OpenSlice supports cloud-native deployments for both itself, as it can be seen here, via Docker Compose and Helm chart, but also for the respective deployments. So what OpenSlice does, since its final, the latest release, is to capitalize on the Kubernetes ecosystem, and particularly at the custom resources. So what it does is wraps around custom resources and expose them as TMF APIs. This way, we can enable the broad ecosystem of developers at Kubernetes to capitalize on their own knowledge and create more complex orchestrational scenarios without imposing many complexities. So we can reuse the ecosystem of Kubernetes. And of course, these complex scenarios or the new, let's say, method of deploying services can be injected in more complex service bundles. So in a more illustrative way, we expect to have a Kubernetes cluster. Someone will develop a controller within the cluster in any programming language, and this, in terms of Kubernetes, is called a custom resource definition. So the custom resource definition passes through the filter and arrives at OpenSlice, and it's mapped to the TMF world as a resource specification. And this resource specification is used in service specifications, and exposed to the customers. So when the customer orders the exposed service specification, the orchestrator should orchestrate the respective resources or the instances of the resources out of the specifications, which they map directly on Kubernetes resources, custom resources, secrets, etc. This is also exposed as a service to the customer because, remember, the customer orders services that incorporate resources and is exposed directly to the customer. This can also support a multi-cluster environment because the component that is responsible for this transformation, namely CRIDS, which is a short name for CRD to TMF bridge, can be replicated, duplicated rather, and support many clusters when connected to a common service bus. So this is the way that OpenSlice can support multi-cluster deployments. These are the respective UIs that are mainly built out of the layers imposed by TMF. So this is the reason that you can see service, product, and resource UIs, and also an UI that enables the user to manage NAV artifacts. So you've spoken about specifications, or what the user actually sees when browses OpenSlice. Specification is a service blueprint, if I may say, or is an artifact that describes what the customer will receive when they order it. So a service specification, a customer-facing specification, can be a bundle of others, but at the end, it has to contain a resource-facing specification that will actually provide the ordered service. This specification references resource specifications that we enable through CRIDS exporting, that in the Kubernetes model paradigm, it references Kubernetes CRDs. So when this specification is ordered, then the instance, the running instance of the respective service is being created as shown at this schema. The respective hierarchy of specifications are followed by the services, and as you can see, running resources are being created in the TMF world that are one-to-one map to Kubernetes resources. A similar concept is followed for the NAV model. So the respective resource-facing services now referencing network service descriptors, which are synced by underlying registered NAVOs. By the same concept, we have running services that are referencing a network service running in the NAVO. So how can we move from service specification to service instances? Through service orchestration is the answer here. So a service orchestration provides the recipe on how to bake the cake, as we say. The service instance, as you may see here, tries to comply with the life cycle of the network slice imposed by 3GPP. So we have some convergence with the standard, so people will know what they expect around the services. But the services, as they seem in 3GPP, are mapped to the TMF model state. So the component responsible for the service orchestrator is awesome, as it is called in short, OpenSlice Service Orchestration and Order Management. It is based on the open source Flowable business process engine, and incorporates many diagrams, business process diagrams, as you can see, that encapsulate all the orchestrational schemas that would like to support. But what happens when a user wants to inject specific codes in the predefined, let's say, orchestrational schemas? So this is where we developed this new concept of dynamic orchestration, and is achievable by lifecycle management rules. Here, once more, the 3GPP lifecycles comes into use, and you can see that these rules can be injected in specific landmarks within the lifecycle of a service as it is appearing in 3GPP. Before the service is being created, during creation, after activation of the service, while the service is running, and after deactivation of the service. This happens in a no-code paradigm, and we expect that the designer will design something with Blockly, which is an, offered by Google, in sense of, let's say, blocks. So as you can see here, these blocks are translatable in real time when the orchestration passes its own landmark. This is a table that, of course, we shouldn't exhaust, but these are the supported TMF open APIs that we currently have. And this list is growing larger each and every release. So last but not least, I would like to emphasize that this work. So the majority of you will be familiar with the generic slice template of GSMA. So this tried to bridge the gap between the service customer and vendors, imposing some characteristics, if I may say, that try to capture holistically a 5G, let's say, network, or the demands that the customer will have from a 5G vendor. So all this free text or these properties of this template were mapped by OpenSlice towards TMF service specification. So someone can order a TMF service specification injecting specific properties of the generic slice template. So some usage examples here. As you can see on the right, this is the research ecosystem that fueled OpenSlice through the years. It started with 5G in Fire back in 2017, if I'm not mistaken, and the history continues with SNS today. And also it affects and uses standards, as you can see on the left side of the screen. Particularly for standards, OpenSlice is a piece of HZSM landscape, and it also participated, if I'm not mistaken, in the POC of ZSM, and I think it was the second POC. In terms of TM Forum, OpenSlice tries to provide feedback back to TM Forum and is aiming for a TMF conformance certification in the next release. In terms of 3GPP, you've seen that specific principles of 3GPP are taken into consideration. And last but not least, the GSMA involves the templating of the latest GST versions. So what is the SDG OpenSlice vision? We started in the first release with a cloud-native OpenSlice, fostering support for Kubernetes. Then we aim to provide a network as a service OpenSlice by the end of this year. So this will have to integrate monitoring so as to close loops. It integrates with another SDG, namely the Teraflow SDN, that you can see in the respective demo upstairs. And it try to provide ready-to-install services when someone installs OpenSlice for the first time. Moving towards the second quarter of 2025, we aim to actually assert the TMF conformance through the respective pipeline at TMF. We would like to have an integration POC with OpenCAPIF. We would like to also have a POC with Camara. And we would like to have multiple UI enhancement for that reason. And most probably we'll integrate an LLM prototype. And at the final release of the next year, we would like to state that we will have an intelligent OpenSlice with more AI features and, of course, indent services. So this figure came up quite some times today, and this is where we aim that OpenSlice stands today. So it is clear, utilizing Operate APIs and TM Forum APIs, that the box of operation and management is quite clear. So during this release, we are studying the architectural documents, and we try to expand towards the holistic coverage of the operate APIs, the red APIs that you can see here, which are provided by TMF. And then, in the next release, we aim to build on top of that, so as to map specific service API requests towards these operate APIs. Something to note also here, at the southbound, all these operate APIs will mean nothing if we don't have the respective controllers that they actually command the network to do as we like. So for this reason, the cloud APIs that we've mentioned are there. The integration with transport network is here through IETF, and also we are exploring other controllers as well. So, thank you. So, OpenSlice under ETSI. This was initially, let's say, kickstarted at previous October, and this is the ETSI members and participants at OpenSlice table. The contact information is here. It is clearly known also via the social media, and I think that concludes the presentation. Under 1 minute, I think.